Hey class, 3.3a is an intro to compound inequalities and graphing them on a number line. So pause and start with the warm up and just review graphing inequalities on a number line. Okay, if you reviewed this, we want to put our number that we're looking to graph in the middle and then a couple numbers to the right. Remember, whatever we're counting by needs to be an even interval, so I chose to count by ones. 2, 1, 0. Greater than 3, so open circle at 3 and to the right. The next one says x is less than or equal to -5. So -5, when I count to the right, I'm going to count up. So -4, -3, -2, -1, 0. To the left, it would be like -6, -7, -8. Because as you go to the left, it gets more negative. This one have a closed circle at -5, and then you would be going to the left. Okay, I'm just going to do those two for you to check for the video's sake and moving on. Today we're talking about compound inequality. A compound inequality consists of two distinct inequalities joined by the words and or the word or. An and inequality is the graph contains the overlap of the two inequalities. So you're between between numbers here. And the or contains the graph of two inequalities, and these ones are on the outsides. That's how I remember it anyway. So inequalities with the word and. This inequality that you see here reads as x is greater than 3 and less than 7. So it could be rewritten like this. X is greater than 3 and x is less than 7. Notice that in the inequality, you're reading it from the inside out. The x, and then the inequality is pointing to the 3. So if I flip that around, it'd be x. The inequality is pointing to the 3. X is greater than 3, and then I have x is less than 7. That one, the inequality is pointing to the x, so x is the smaller one. The solution must be both greater than 3 and less than 7. It's going to look like this on the number line. So I need to go from 3 to 7, so I'm just going to start at 0. 1, 2, 3. Okay. These are both less than symbols, so no equal to. So I'm going to have an open circle at 3 and an open circle at 7. And then it has to be greater than 3, so to the right of 3, and less than 3, 7, so to the left of 7. So you'll see that they'll overlap. So when you graph this compound inequality, you end up connecting the two dots in an and situation. One solution to this inequality would be like x equals 5. Any number between 3 and 7, not including 3 and 7 because of the open circles, would be a solution. Okay, this one means that if we read it from the inside out, this means that like x is greater than -2 and x is less than or equal to 5. So x is greater than -2 and x is less than or equal to 5. So I would start by maybe plotting -4 and then working my way back. -3, -2, -1, 0, and then 1, 2, 3, 4, 5, 6, 7. So making the number line. So pause the video if you need to pause and make that number line. And then I have x is greater than -2. That's an open circle at -2, and I'd be going to the right, bigger than -2. Then I have less than or equal to 5. That's going to be a closed circle at 5, and then less than 5 is to the left. So I'll see that my answers overlap again. So I connect my two dots. My solutions are in between -2 and 5. One solution could be 0. That'd be a number that's in between, somewhere that falls on the line that I drew. Okay. Graph this inequality. This one reads from the middle. If I rewrite this piece in the middle here, x, and then we're pointing at the 3. So if I rewrote it, I'm still pointing at 3. So that means that x is greater than or equal to 3 and x is less than or equal to 12. So x is greater than or equal to 3 and x is less than or equal to 12. So let's see, we might have to count by 2s to fit these on. So 2, 4, 6. So greater than or equal to 3, 3 is going to be right between 2 and 4. It's equal to 3, so it's going to be a filled in closed circle. Greater than or equal to is going to go to the right. And x is less than or equal to 12, so equal to 12, so closed circle again. And the numbers to the left, so then they overlap, so we would connect those dots. So that's a compound inequality. Then any solution here between 3 and 12 would be an answer, including 3 because it's equal to 3. So 3 could be a choice, or 6, or 9, or 8.5, 11.9, etc. So those are and inequalities. They connect in the middle. It's between the two numbers. They're both greater than 3 and it's less than 12. Like the number 8. 8 is greater than 3 and it is also less than 12. It's an and inequality. Then we have an or inequality. So this is where it specifically has the word or in between. So this statement says the solution must be less than 3 or it must be greater than 7. So that's going to look like this. Let's see, we'll start at 0. So I just counted by ones. X is less than 3 is an open circle at 3. Less than is like 0, 1, 2, 3, so to the left. Or x is greater than 7, so an open circle at 7, but greater than 7 is to the right. So the or inequalities face the opposite direction. One solution to this could be like 0. So 0 is either less than 3 or it's greater than 7. So 0 is less than 3, so that it works. X equals 10 could be a solution because it's not less than 3, but it says it's or greater than 7, and 10 is greater than 7, so it does work. So that's a solution. We'll do one more for the video. This one means x is less than -3, or, and then the next one says x is greater than or equal to 5. So I got to graph some negatives. So I'm going to put 0 right here, and then I'm going to go -1, -2, -3, -4, and then 1, 2, 3, 4. Count that way. So the first one, or x is less than -3. So it's going to be open circle at -3, and we're going to the left. Less than -3, not including -3. X is greater than or equal to 5. That includes 5, so closed circle. And then 6, 7, 8 are bigger than -5, so greater than or equal to goes to the right. So in or inequality, they face opposite directions. One solution, you could have 5 because it's a closed circle. You could have -4, -12, anything to the left of -3, anything to the right of 5 would be solutions to the or inequality here. All right, please do 3.3a homework after watching this video.